Well, once again, it's the weekend. Today is Sunday, and I've got this hankering for some fried potatoes and onions, you know. I wanted to cook them outside over an open fire, but the snow is out there in the mud and the muck, and I don't want to mess with it. So I'm cooking them in an iron skillet here in the house. And so far, they're looking real good. The spices I'm using on these fried potatoes are, you know, some sea salt and some onion powder, garlic powder, some seasonal, and of course some paprika and black pepper. And that's about all. I'm cooking them in some olive oil, and I'm going to really brown them up. They're not fried potatoes sliced; they're home fries, and I'm really looking forward to it. Boy, they're looking good, better by the minute. Now, before I put them in this frying pan, I did some pre-cooking in the microwave oven. I cooked them for about 5 minutes after I cut them up. Put them in a bowl, and just, you know, cooked them 5 minutes, and took them out and put them in here, and they'll cook a lot faster. And I'm cooking them completely from start to finish on medium heat. Time for the onions. Yes, time for the onions. Getting back to our hot transformer problem in our Hammerlin HQ129X, for those of you who have been keeping up with it, I went ahead and pulled the rectifier tube because, you know, Mr. Mac 5150 said disconnect the secondary of the transformer, and, you know, if it still gets hot, then you know it's not anything in the chassis, it would be just the transformer. Well, I don't have to do all that. All I have to do is pull the rectifier tube, which I have. And then it's been running for about an hour. So let's find out what the temperature is. Not bad, 105 degrees. In between taking temperature readings, I'm watching reruns of the Rocky movies. I'll tell you what, I could watch those Rocky movies 1,000 times and still come back and want to watch them more. They were so good. All right, let's take a reading. Ron C. said that, you know, you've been taking readings of the core. Our good subscriber, Ron C. He says, you're taking readings of the core. Why don't you try taking readings of the clamshell too? Maybe you'll get a difference in temperatures between the two. Because, you know, this thing is designed to dissipate heat. He had a good point there. I hadn't thought of that. So that's what we're going to do now. Let's take a reading here. Now, this thing's been running at least an hour with the rectifier tube in there. Here we go. Let me get this light out of here so we don't have to have the glare to mess with, I hope. Yeah, there we go. All right. 135, 136, still going up. Looks like that's the max. All right, now let's go over there. That's on the core. Now let's go over here and hit the clamshell itself. All right, what I'm getting there is a lot of heat from that rectifier tube. Let's get way over here, away from it. All right, it is going down. 127. That's not bad. That's not bad. I think old Ron may just have had something there. But at least for below 130. Now let's go to the other side where there is no rectifier tube. It goes way down. I don't know. I just can't. It just seems to me it's still running hot regardless of how I take the temperature. Yeah, it's cooler on the sides, but yeah, I don't know, that old rectifier tube, that thing really runs hot. Let's do a little reading of that. Yeah, look at that baby. 260-some degrees. Oh well. We'll keep working at it. By the way, someone else came up with the idea of, I like the idea. He said, buy a 12-volt fan, which, you know, that's been an issue, you know, an option since the beginning. We knew about that. Hooking it up would have been a way, and how would I have done that? He had a great idea. Pick yourself up a 12-volt fan. He said, run it off your dial lights, which I can do, which would be 9 volts or something like that. Glue some magnets in each corner of the fan and just stick it to the back here. Let the magnets hold it. I think that's a great idea. I'm going to really explore that one. You know, this hot transformer in the Hammerlin HQ129X is getting to be more and more interesting, and not from my standpoint, but it's getting to be more and more interesting because it gives me a chance to show some of our newbie friends, and I'm talking to ones just coming in, a few things that they may not have noticed on some of the schematics that they've dealt with. It took me a while to notice one thing until all of a sudden one day it was like, hey, this can't be right. And good old Antique Radio Forum member, now deceased, Kurt Reed, he told me, yeah, that's the way it is, John. I'm surprised you hadn't noticed it before now. Anyway, I've decided to use a cooling fan out of a computer to cool the transformer down in the Hammerlin. Now, this was suggested by one of our good subscribers, Wayback Tech. I had already thought about that because I had read about it on the Antique Radio Forum and various places throughout the internet. And, I was kind of waiting, well, maybe there's another way we can do it, And then, anyway, it ultimately came down, and he recommended, he said, John, go to the place where you buy your computer, Connecting Point, here in town, and ask them if they have an old cooling fan out of a computer tower. Well, of course, I walked in, I told them what the problem was. I had a hot transformer. I'd like to buy a computer fan. Do you have any? They took me in the back room. My God, they had a box full of them. Huge ones that would run off 120 volts all the way down to these little puppies here. I decided not to go with a really tiny fan. That's not what I want. That transformer is cooking at about 130 degrees Fahrenheit, a little bit higher the longer you run it. I wanted something that was really going to cool it. So he gave this to me. He said, I don't need it. He said, I got a box full of them. He said, you spend enough money here, a little gift to you. I tried to buy it. I said, no, you're not here to give away the profits. He said, don't worry about it. Take the fan. Okay. I took it home, and I cleaned it all up. She's ready to go. This is a 12-volt fan. I never heard of sunning. I took what the guy gave me. I wasn't about to be, let me see if I can get a little focus in here. It draws 2.1 watts, okay? That's what she looks like. I don't know where it's made. I just know it's made in China. Is anything not made in China? Anyway, so all we have to do, you newbie types, all we have to do, it runs off at 12 volts, like I said. We can run it at half that voltage, and it'll still do the job. And all we have to do is find a source of about 6 volts somewhere in the Hammerlin schematic and just tap off of it, and that should run it. Well, if you take a look down here, all of these tube filaments all have 6.3 volt filaments, and the bulb here, these bulbs, they run I think it's 6 to 8 volts. So I can tap off of any one of these bulbs and any one of these filaments, and that will power our little fan. Every time we turn the computer on, it'll start the old fan going, and that'll keep the transformer dry. No, it'll keep the transformer cool. I'm having a tough time here today. So that's all we gotta do, right? Wrong. That's not what we have to do. I've blown up this section before. I'm going to use the same drawing to show you why we cannot do that. You newbies, you pay attention now. This is very important. Some filaments on tubes run off of DC voltage. Some run off of AC, and some run off of either AC or DC. Now, all of the filaments in the tubes that you see here, the 6SS7, 6K8, 6H6, 6V6 on down, these tubes run off of either DC or AC voltage. Well, this is a DC fan, so I should be able to just hook, if these are running off either AC or DC, I should just be able to hook up and go with it, but I can't. Here's why. Look back here. What's feeding these filaments? What's feeding these filaments is the secondary on the power transformer. That's AC voltage right there. Up here is AC also, but it's being rectified to DC. Down here there is no rectification. It's coming straight out of the transformer secondary as AC voltage going through and powering all the heaters and the light bulbs in the radio. So I can, yeah, 6 volts, but it's AC. I can't use it with this fan. But there is a way we can do it. I'll come back and tell you what that's all about. What you're looking at is a 50 volt bridge rectifier rated at 4 amps. We don't quite need one that big or as far as current handling capability, but what the heck, you know, it's only $2.99. Go for the overkill, folks, and we certainly don't need 50 volts. I mean, we're talking about 6.3 volts coming off those light bulbs or the filaments. But what the heck, for $2.99, not a big deal. I could hook the filament leads to the 2 center leads on this thing and then hook the fan to the 2 outside. And what that would do is completely rectify the AC voltage coming off of those tube filaments or those light bulbs, turn it into DC and feed it straight into the fan. It would work. It would work great. All you have to do is a little bit of soldering, a little bit of relocating. Piece of cake to do something like that. Of course, once the voltage is rectified, you know, it's going to look like this. It's going to be pulsating DC, like that. We don't really want to feed that kind of DC into our fan. It's the same kind of voltage that's coming out of this thing right here, or for that matter, these are the 2 diodes I had in that tube socket, or what's coming out of the 5U4, if I can find it on here and down here, yeah. The 5U4 is also putting out the same kind of rectified DC voltage along here. What's coming out is, it looks like this, same thing, and then they run it through 3 filter caps here, which smooths out, and they also run it through a couple of chokes, which opposes AC voltage. And what they do is knock the tops off those babies just like that, turn it into straight DC voltage. Okay, so that's what I would have to do. Is once I hook the rectifier up, I would have to take the positive side of the line and connect a DC, just like you see it right here. I'd have to connect a small capacitor, electrolytic capacitor, to ground, and rated at, you know, 50 volts or so to ground, and that would smooth out any of the humps. And it doesn't have to be perfectly smoothed out. I mean, we're just dealing with a fan here, but it would smooth it out enough that the fan could work and run at about half its normal speed. And we can do it that way. So which way do we want to do this? Do we want to go ahead and, you know, set up this entire rectifier capacitor deal, or is there yet another way? Yes, there is another way. What I've decided to do is to go ahead. Fortunately, this thing came with 2 plugs, one male, one female. This is great. That is really going to come in handy. I'm going to remove this plug and the wires out of this connector here, and then I'm going to turn that baby around, and we're going to hook this end into a wall wart that puts out 9 volts. Okay, 9 volts DC, and then we'll take this end and plug it into there. That way, I can just separate the wall wart from it at any time I want simply by unplugging it. Then I'll have 9 volts going into here as opposed to 6.3 volts, which we would have gotten from the filaments or the lights after it was rectified. So it'll run a little bit faster. I don't want this thing running full speed, you know, but I would like it to last a little long. And with the help of some of the people I work with, I might be able to come up with I've come up with an idea. I just didn't want to, you know, stick it on the inside of the, you know, the Hammerlin metal case like everybody else does. I wanted to do something different. And I came up with, I wanted it to be easily removable and easily unpluggable. And the next guy, when he gets this radio, won't even know it was in there. It'll, of course, be included with it. And he can do with it what he wants. Or she wants. Anyway, stand by to see what we're going to do with that. I probably won't have any results until the next Mish-Mash video, okay? There's one good thing about getting snow in Arkansas. It's here today and gone today. A number of months ago, one of my coworkers came up to me and said, "John, out behind the barn on my property, there's a junk pile. It's been there for a number of years, and in that junk pile is an old ham radio. I was wondering maybe if you'd like to have it." I said, how long has it been out there? For years? He said, yeah, it's been in the rain, the snow, and all that. I said, well, I don't know. I said, I'll tell you what, take a picture of it on your iPhone, bring it in, and let me look at it. So he did. And this is what this is what I saw. And I said, well, that's pretty interesting. It looked to be in fairly decent shape. In other words, the ice and snow didn't really tear it all up. Visibly anyway. It's bad, but not that bad. But interesting, anyway, he brought it in, and the interesting thing is, look at there, the tuning dial turns good. The rest of them are frozen, nothing, a couple of them are turned, I guess. That's about it, not too many. Most of them are all just frozen, a couple of work. Anyway, he brought it in, I brought it home, and I didn't know what it was. I looked all over. The nomenclature tag, of course, is all rusted. I tried everything to get an impression on that, but I couldn't bring anything out. So I made a video of it and posted it to the Antique Radio Forum, and they found out for me what this is. There's always somebody on that forum that knows something about something. It's amazing. This is an RCA RBC-5. It's a 4 to 27 megacycle receiver, and apparently someone was using it as probably a general coverage receiver. That's the only thing I can think of. It does come with a power supply. I'll show you a couple pictures of that in a minute. And it was used aboard Navy ships, and it was built very strong, very strong. If the ship got hit by a torpedo, you don't want your comm gear to just rattle so bad and it just quits working. No, this kept that from happening. And every time they fired those big old guns, and the ship shook and rattled and all that crap, they didn't want the comm gear to crap out by that also. And it's real. Look at how thick the metal is on this thing. Look at the faceplate. That is solid. That is solid metal on that thing. This thing, by the way, was built in 1952, and they kept these things on board ship, even though there were better radios that had come out since the 50s. They kept this thing on board those ships until 1960, or maybe even a little bit later than that, because they were so good and so reliable. Anyway, I doubt if I'll ever get around to doing anything with it, but I am going to crack the thing open. And we're going to take a look at it as soon as the weather breaks. It's a little bit too cold out here. I think this thing has been painted, because these knobs, these knurled knobs are painted, and normally they were metal covered like this right here. This should be that color you see right there without the paint. It should be a knurled metal, but it's not. So someone has laid some paint out over the top of the old paint. This in the original was supposed to be black. That panel right there. I'll show you a few pictures that I printed off on the information that I found as a result of those folks on the Antique Radio Forum helping out. Here's what the radio looked like in 1941. It was all black, of course, and at that time it was called the CRV 46148 radio receiver. And then they painted it gray and did a bunch of upgrades to it, and it became the RBC-5. And that was in 1952. This is what it looked like when it was new, by the way, after the upgrade was done. It does have its own power supply, and this is a part of it. Let's see if I think I have a picture. This is the front panel, by the way, with all the knobs. I wanted that picture in case I decide someday. I don't know. I probably never will, but Anyway, it takes a 600 ohm speaker because it was originally designed for use with headphones. 600 ohm impedance headphones. On board ship, they didn't need a bunch of speakers blaring away, so all the commo guys all wore headphones. But you can put a speaker on it. According to the information I found out, you just won't get a really loud sound. And let's see what else I got here. It's kind of interesting. Some of you may, once I crack it open, this is kind of part what we're going to find in there. One side is the RF, the other side is the power supply and the audio section. I don't know. We're probably going to find nothing but a bunch of rust when the time comes, when I ever decide to open it up. This is what the power supply looked like. The power supply was also very rugged on this thing. Extremely rugged, because, if a ship got hit by a torpedo and the lights were flashing and there were surges flying everywhere, this thing here was designed to take those massive surges and keep the commo gear operational. They're really interesting. And it could also power 2 of these receivers if need be. I mean, it was only designed to do one, but there are 2 connectors on this thing that you can hook 2 receivers in case you lose one of your power supplies. I thought that was really cool. And that's about it. There's not much out. This is what the back of it looks like. There's one of these plugs on the front and the back for use with two. Well, I hope you find that interesting. So sometime in the future, we'll pop that baby open to see what she looks like. Let's go ahead and wrap this video up with a little demo involving this little fan that I plan to put in my Hammerlin. Quite a while ago, our buddy from over there in England, his name is Phil, our good subscriber, Steel City 321 PB. He watched a Mish-Mash video that I did where I cleaned the tower, my computer tower, and I was blowing air down in there, you know, and blowing all the dust out and everything, and I was blowing it out of the fan, and out of both fans, actually, the one in the back where the power supply is, and the one, there's another one in there someplace, I can't remember. Anyhow, I was just blowing away, and that old fan was just whizzing around there. And he contacted me, he said, John, you know, you want to be careful doing that with air, because these things actually generate voltage. And it's feeding back into your motherboard, and you can blow out some small components that don't take that kind of voltage. Well, I'll tell you what we're going to do. You know, when I read that, I said, you know, that makes sense. I should have thought about that, and it didn't even dawn on me. And now that I have a fan, we're going to go ahead and give it a little demo. So suppose you're in there, you know, blowing air out of your computer tower, and you got that old fan just whizzing. Let's see what happens. Let's go to AC voltage, 20 volts, okay? And I've got me a little can of air here today. We're going to get that baby whizzing with the can of air. And I want you to watch what happens with the voltmeter here. Okay, here we go. All right, let's do her slow this time. I think there's a limit to you know, the voltage that it will generate. We're up to all right, just keep that in mind. So what can you do actually to prevent that, you know? Well, you can unplug it from the motherboard until you're done and then plug it back in, or you can put something in the fan blades like this that'll you know, keep them from turning while you blow the dust out. Well, that's it, folks. We're going to go ahead and wrap it up. That's it. And next time, I got a goodie planned for you next time on the Mish-Mash video. I think it's the Mish-Mash video. We're going to go ahead and keep working on this business here. So until then, this is John.